VIVA questions for the salt analysis. It's by Chemistry Corner. Question number 1. What is the chemistry of flame test? In flame test, the valence electron of an atom gets excited and jumps to the higher level. The electron jumps back to the ground state. The radiation is emitted, those frequencies fall in the visible region. Question 2. Why do we use corn HCl in preparing paste of the salt for flame test? In order to convert metal salts into metal chlorides, which are more volatile than other salts. Carbon dioxide and sulfur dioxide both turn lime water milky. How will you distinguish them? By passing through acidified potassium dichromate solution, sulfur dioxide turns potassium dichromate green while carbon dioxide has no effect. So the next we have to recall the group reagents and cations and how these cations are precipitated in salt analysis. Group 0, there is no separate group reagent. For group 1, group reagent is dilute HCl and the cation present in group 1 is lead Pb2+, and it is precipitated as their chlorides. Group 2, it is precipitated as sulfides. The group reagent is H2S in the presence of dilute HCl. The cations are Pb2+, Cu2+, arsenic 2+. Group 3, the group reagent is ammonium hydroxide in the presence of ammonium chloride. The cations are Fe3+ and Al3+. And here it is precipitated as their hydroxides. Group 4, the group reagent is H2S in the presence of basic medium ammonium hydroxide, and the cations are nickel 2+, Mn2+, and Zn2+, and cobalt 2+. They are precipitated as their sulfides. Group 5, it is a group reagent is ammonium carbonate in the presence of ammonium hydroxide, and the cations are Ca2+, Ba2+, and strontium Sr2+. They are precipitated as their carbonates. Group 6, the cation is magnesium. Here there is no separate group reagent. So condition for cation analysis. Here condition for precipitation is solubility product should be less than the ionic product. Or in other way we can say the ionic product should be greater than solubility product. And cations are separated or grouped based on their common ion effect and solubility product. So here we have seen that group 5 cations are calcium, barium and strontium. In periodic table if you are seeing they are present in group 2, but here it is group 5 because all the three are precipitated as their carbonates. So and based on that they are grouped here as group 5. It is essential to add dilute HCl before proceeding to the test for the basic radical of group 2. So it is also due to the common ion effect. For the group 2 cation precipitation, low concentration of sulfide is enough. So in order to suppress the sulfide ion concentration, here the HCl is used. HCl being strong acid, it ionizes as H plus and Cl minus. So here H2S also gives H plus. So both places H plus is common ion. So it suppresses the sulfide ion. Due to the more H plus, according to Lee-Chatelier's principle, the backward reaction, that is H plus and S2 minus goes to backward. So a little concentration of sulfide ion only present. That is enough to precipitate group 2 cation. So here that's why group 4 hindrance is prevented. So low concentration of sulfide is required. So that's why here HCl is added in order to create common ion effect. Why is ammonium chloride added along with ammonium hydroxide in group 3? So in order to decrease the concentration of OH minus ion by suppressing the ionization of ammonium hydroxide by common ion effect. If ammonium hydroxide alone is used, in that case, the concentration of OH minus is enough to precipitate the hydroxides of 4, 5 and group 6 also. That's why in order to suppress as for common ion effect. What is blue lake? It's a blue particles, that is blue litmus absorbed on the white precipitate of aluminum hydroxide in colorless solution. Same way, H2S gas is passed in the presence of ammonium hydroxide in group 4, that is a basic medium for group 4. Explain why. So here also due to common ion effect. Here that H2S ionizes as H plus and S2 minus. Ammonium hydroxide ionizes as OH minus and ammonium plus, and here H plus and OH minus gives water. So the removal of H plus ion from the solution causes more of H2S to dissociate, thereby increasing the concentration of S2 minus ion to such an extent that the ionic product of fourth group metal sulfides exceeds the solubility product, hence they are precipitated. Presence of ammonium chloride is quite essential before the addition of ammonium carbonate in group 4. Explain. Ammonium chloride suppresses the ionization of ammonium hydroxide and ammonium carbonate due to the common ion effect, which results in decrease in the concentration of OH minus and carbonate ion. So the ionic product does not exceed the solubility product of magnesium hydroxide and magnesium carbonate, and thereby they are not precipitated in group 5. Thank you, children.